right, guys, the last thing we need to look at is when we do a lab, what our actual product is going to be. Because we've been so far talking about theoretical amounts. If we were to theoretically do this reaction, how much product we would get. Well, that's all fine and good, but when you do a lab, you don't necessarily get your theoretical yield. And so we need to talk about how to compare what you actually get in a lab to what you theoretically should have gotten when you are creating a product. So when we're talking about percent yield, we're going to be dividing the actual yield, which is how much you get when you do the lab, what is actually produced. We're going to divide that by the theoretical yield. And the theoretical yield, that's the calculated number. That's what we've been calculating when we have been doing stoichiometry. So when we do labs where we're creating products and we're measuring how much did we make, we're going to be calculating the percent yield rather than the percent error. When you're finding percent error, you're comparing something to an accepted value. When you're finding percent yield, you're comparing something to the theoretical yield of whatever that product happens to be. Okay, so let's do an example. So here's our problem. It says solid silver chromate forms when excess potassium chromate is added to a solution containing 0.5 grams of silver nitrate. So the first thing we need, as always, is to write our balanced equation. So the potassium chromate is reacting with the silver nitrate. So we have AgNO3 reacting with K2CrO4. This is a double replacement reaction, so the silver and the potassium are going to replace each other. It tells us that solid silver chromate forms, so that's our precipitate, Ag2CrO4, which means the other product will be potassium nitrate. And when we look at those charges, potassium is +1, nitrate is -1, so we write it KNO3. And then when we balance it, we need 2 silvers, so we put a 2 there. We need 2 potassium, we put a 2 there. Okay, so there's our balanced equation. Now the question says solid silver chromate forms when excess potassium chromate is added to a solution containing 0.5 grams of silver nitrate. It's telling us here which one is the limiting reactant. It's telling us that we have excess potassium chromate. That makes silver nitrate the one that's limiting, so we don't have to figure that part out. So the first thing we want to do is determine the theoretical yield of silver chromate. Okay, so we're going to start with what we have, which is 0.500 grams of AgNO3. And from there, we want to calculate the mass of silver chromate. That's what we're trying to find. So we convert our grams to moles. With the molar mass of silver nitrate, which is 169.872. Our grams cancel. Then we need our mole ratio. So we put our silver nitrate on the bottom, and we have 2 moles of silver nitrate. And we're trying to find silver chromate, and we have 1 mole of that. And then we want grams of our product, so we need the molar mass of silver chromate, which is 331.728 grams per mole. Okay, let's see, those moles canceled, so we have grams left, and when we do that calculation, we get 0.488 grams of Ag2CrO4. Okay, so that's our theoretical yield. When we do this reaction, theoretically, that's how much product we should get. Okay, so that's the answer to the first question. Find the theoretical yield. Now, the second part says calculate the percent yield if the reaction yields 0.455 grams of silver chromate. So this number right here, this is the actual. you either have to be given that number in a problem, or when you do a lab, your mass of your product will be your actual yield. So that's not something you can calculate. You have to know that in a problem like this. You have to be given the actual yield. So to find the percent yield, we're going to take our actual, which is 0.455, divided by our theoretical that we calculated, 0.488 times 100, and that gives us 93.2% yield. Now in this case, you want close to 100, because if you get 100% yield, that means you made exactly how much you were supposed to. So it's kind of the opposite of percent error. You want a really high percent yield, whereas before we wanted a low percent error. So 93.2%, that's a pretty good yield. Okay, so make sure you know that percent yield formula. We will be using it when we do lab calculations.